So in this video we look further into the section 3.7 idea for how to find the tangent line to an implicitly defined function. And at this stage of where we are, we know that if we want to find a tangent line, we need the slope of a line. And we know that there's a relationship between slope of a line and the derivative. Okay? So in this video, we're going to specifically talk about how to take the derivative of an implicit function. Okay, how to take the derivative of an implicit function. And this is also known as implicit differentiation. Okay, so this is one of the topics from section 3.7. Okay, so for example, okay, as kind of like a warm-up and a recall. Okay, recall that we've looked at the problem before that if you have some unknown function f of x and you want to square that function, and we call that, say, this function h of x. Okay, if you want to find h prime of x, also known as the derivative of the function h, these are the same notation, same idea, different notation. Different notation. So if we want to find the derivative of this function x, we need to recognize that there is a chain rule involved. There's an outer function squared. So when you take the derivative of the outer function, you take the derivative of the squared function with the power rule. And then there is the derivative of the inner function. The inner function is f of x. So the derivative of the inner function is f prime of x. Okay. So here is the derivative of h prime of x, and you're done. Okay. So one thing that happens in this section, instead of writing f of x, remember that sometimes y is also written as f of x. So instead of f of x, they will also write y, and it's our job to remember that maybe y is just a different notation for f of x. So instead, the problem could have written that h of x is y squared, where y is equal to f of x. They could have just written this, and it's up to us to remember that y is equal to f of x. So then if you're asked to find the derivative of h with respect to x, right, there are still two functions involved here. The outer function, which is the squared function, so you would do 2 times the outer function, the derivative of the outer, which is 2 something to the first power, and the inner function was y, and then you have to take the derivative of y with respect to x, okay, which is also called 2y to the first power times y prime, which is the same thing that we wrote up here. If you would replace f of x with y, and you would replace f prime with y prime, you would have gotten 2y times y prime. Okay. So in this section 3.7 section, they're going to replace explicitly the function f of x. They're going to write y implicitly as a function of f of x. Okay. So how does that help us? Okay, so the example I'd like to look at now is that let's look at an implicit function and its derivative. Okay, so for example, you could have xy plus x plus y is equal to 5. Okay. And here is an implicitly defined function. This will be given to you. Okay? And then the question is to find what is the derivative of y with respect to x. What is that? Well, the steps to go through, step 1 would be to take the derivative of both sides of the equation. So let's take the derivative of the left-hand side Okay, and then let's take the derivative of the right-hand side. Okay. Right, and we'll need to go to another page to finish those steps. So that's what we want to do. Step 1, take the derivative of both sides of the equation. Okay. So that leads us to taking the derivative of xy plus x plus y is equal to the derivative with respect to x of 5. Okay. But remember, properties of the derivative says that this derivative, if things are added to each other, you can take the derivative of each entry separately. So I can take the derivative of all the entries separately and then add the results together. The derivative of 5 is equal to 0. Okay. This derivative right here, the derivative of x times y, happens to be two things being multiplied, x times y. So its derivative is the first times the derivative of the second plus the second times the derivative of the first. Okay, the derivative of x is equal to 1, and the derivative with respect to x of y, we need to ask what that is. Okay, now it would be natural to say that the derivative with respect to x of y is equal to 0. That's what you want to do, because there's a variable mismatch. Y, you're saying, doesn't have x's in it, so it would be a constant with respect to x. So that's what you want to write, but unfortunately that is incorrect. Okay, because in this section 3.7, we're thinking of y as implicitly written as f of x. Okay? So wherever you see these y's, that sends us back to y was actually a function of x. Okay? Derivative of x with respect to x is 1 plus 1 plus the derivative with respect to x, y was equal to f of x. Okay? Now, the derivative with respect to x of f of x, this is what we call, in section 3.7, they're going to call this y prime. Okay, so xy prime plus y plus 1 plus y prime is equal to 0. Okay, and that is the end of step 1. You've finished taking all your derivatives. Okay, and now step 2 is to do an algebra solve for y prime. Okay, so if you solve for y prime, I'm looking at everything that has a y prime in it, and I'm going to move everything that doesn't have a y prime attached to it. I'm going to move that to the other side of the equation. Okay, and on this side of the equation, both terms have a y prime in it, so I will factor out the y prime. Okay. And now you can do your last step, solving for y prime by dividing both sides by 1 plus x. And here we have found the derivative as a function of x and y. Okay? So the thing to note here is that your original implicit function, notice that it was xy plus x plus y is equal to 5. Notice all the x's and y's that are mixed together, okay, in this implicit function. So it's not surprising that when you take the derivative, note also the mix of x's and y's. Okay, that is okay. It's okay in Wiley Plus to mix your answer for the derivative of the implicit function. Y prime is the derivative of the implicit function. And it's okay if your answer has x's and y's mixed into it. That is okay on Wiley Plus. Okay? So, that is what we need to, that's what we need to figure out. We need to find this derivative before we can find the tangent line. Okay? Let's do one more example. Let's look at an example from the textbook. Okay, here's some implicit differentiation problems. Okay, some functions. Let's try this one for example. Okay, so you're given an implicitly defined function. Okay, so this is what you're given. And the question will be, can you find y prime, also denoted dy dx? Can you find this? Okay. To do that, your step one is going to be to take the derivative of both sides of the equation. Okay. Taking the derivative on the left-hand side, you'll get to take the derivative of each entry separately. Okay, that's the left-hand side, and then you'll get to take the derivative of 0 on the right-hand side. Okay, now let's go through here and see if any of these simplify. The derivative of 5, which is a constant, is 0. The derivative of 0 is equal to 0. Okay. Here's the first term we got to be really careful about. Okay, the derivative of 2y. Okay. Well, 2 is a constant, so it can come out in front of the derivative. So actually, we're going to get minus 2 times the derivative with respect to x of y. Okay, and remember that this is not equal to 0. Okay, because y is actually a function of x. That's implied. Okay, this is the implicit part of the differentiation. We're thinking of y being some function of x. So instead of derivative of y with respect to x, in this section the book denotes this whole term right here as y prime. Okay? So we made some good progress on this problem. We can say that by taking the derivative of one of the sides, we'll get minus 2y prime equal to 0. So okay, I filled in all the terms that I could. Now, we're not quite done yet because we still have a derivative to take. Still a derivative to take. Okay? So let's continue on with that derivative. There is two functions being multiplied, the x squared function and the y, which is equal to the some function f of x. So we're going to need to do the product rule now. It would be first times the derivative of the second plus the second times the derivative of the first. And then there's minus a 2y prime is equal to 0 from here. Okay, so that's step one. You're done with step one after you've taken all of your derivatives. Okay, now step two. Step two was an algebra problem. Okay, and it was to look at all the terms that have y prime and to factor them out. So you'll get x squared minus 2. And then you could add everything that didn't have a y prime, add that to the other side. So negative 2xy. And therefore y prime, when you solve for it, is negative 2xy divided by x squared minus 2. And that would be your answer to this problem. Again, it's okay if there's x's and y's mixed in. Okay? So, the next video will actually, in the next video, we need to talk about how to put all these problems together, all the different steps together to find the equation of a tangent line. Okay? So ends this video.